class, this is Miss McBrayer, and today we are going to be learning an introduction to wave types. So as we go through this PowerPoint and do the activity throughout, I want you guys to follow along on your guided worksheet. At the end of this class today, I want you guys to be able to distinguish transverse and longitudinal waves, give characteristics of each wave type, label the crest, trough, amplitude, and wavelength of a wave, and describe the relationship between frequency, wavelength, and speed. Now, before we do all that, we have to know what a wave is. A wave is a vibration that is a transfer of energy from one point to another. This can look like heat waves, sound waves, light waves. They come in many different forms, shapes, types. But in its most simple form, in most simple definition, it's a vibration that is transferring energy without necessarily moving matter from one place to another. One example that's shown in this picture here is a small drop of water on a calm surface, like when you're at a pond and you skip a rock and the ripples come, or a fish bites off the food at the top of the pond and you see all the ripples from where it came from. The first type of wave we're going to talk about is a transverse wave. A transverse wave has vibrations of particles that are perpendicular to the direction of travel. So as you see in this picture right here, the vibration is moving up and down, and the direction of the wave is moving perpendicular to that. And there's 4 parts of a transverse wave that we're going to talk about today: a trough, crest, amplitude, and wavelength. Trough is the lowest point in a wave, whereas crest is the highest point in a wave. Amplitude is the distance between the middle position and extreme position of a wave, so the crest or trough, the distance between. And then a wavelength is how long the wave is from crest to crest or trough to trough. So, on your guided worksheets, we're going to label the parts of a wave. So you see these little green arrows, that's pointing to the lowest part, which is called a trough. Good job. Now the red is pointing to the highest part of the wave, which is called a crest. Great job. Now, the red or the orange up and down represents the level from the middle of the wave to the tallest part, which is the amplitude. Good job. And last but not least, the purple represents the length from a trough to a trough, which is wavelength. Great job. Next, we're going to talk about frequency. Frequency is the number of waves that pass a point in a certain amount of time, which is measured in hertz. So as you see to the picture to the right, some of these waves are really close together, meaning they have a high frequency. And then the one below it, less waves occur, so that has a low frequency. Slinky time. Now it's time to demonstrate transverse waves with the use of a slinky. Let's get to it. Okay, with your partner, make sure one person is holding the end of the slinky and the other person stretches out all the way. To simulate a transverse wave, the person who stretches it is going to move their hand back and forth. And this demonstrates a transverse wave, how the wave is moving horizontally, but the vibration is happening vertically. If you speed up the wave, notice how the wavelength gets shorter, but the frequency increases. Notice when we were doing our slinky demonstration that the faster we made the wave go, the higher the frequency and the shorter the wavelength. Direct co means there's a direct correlation between frequency, wavelength, and speed. The next type of wave we're going to talk about is a longitudinal wave. A longitudinal wave has vibrations of particles that are parallel to the direction of the travel. So as you see, the vibration is moving horizontal and also the direction of travel is. time to demonstrate it with a slinky. Now to demonstrate a longitudinal wave, you're going to have the same partner hold and the other partner stretch, but this time you're going to push the slinky. Notice the parts of compression and how the wave is moving horizontally just like your hand is moving horizontally. This is why it is a longitudinal wave.